AMC 10A 2004, problem 18. We have a series, or a sequence rather, of three real numbers that form an arithmetic progression, with the first term being 9. And if 2 is added to the second term, 20 is added to the third term, the resulting three numbers will form a geometric progression, and we're trying to find the smallest possible value for the third term of the geometric progression. Now, first of all, I would like to establish the given information, which is that the first term is 9, and we have three terms. Now, we have 9, then that means that the following numbers will be 9 plus the common difference, and I'm going to call that n. So the third term will be 9 plus 2n. Now, there's actually very special attributes about a series with only three terms in it, and we'll get to that in just a moment. But for now, there are two options to go. Now we can apply the second given information, which is if 2 is added to the second term, which will be 11 plus n, and 20 is added to the third term, 29 plus 2n, it will form a geometric sequence. So this is arithmetic, this is geometric. Now, if you really wanted to, you can simply plug in every single solution into this series and see if it holds out. And that is obviously very tedious and inefficient. And if you do that, you might make a mistake and you won't be sure whether you did it right or wrong. So to establish a firm foundation for your correctness, we can solve this algebraically and logically. So there are two things to note about arithmetic and geometric series, and that they both contain means. And this means that the arithmetic series, if there are three terms, the middle term is equal to the sum of the three divided by the three. And for the geometric series, it will be called a geometric mean, which is simply the square root of the number of terms that you have. We're going to call it n, with all of the numbers multiplied together all the way to an. And that is a very, very special thing, because the geometric mean, when the geometric series has an odd number of terms, will be equal to the middle term. And that can come in very useful for this question. So we can apply this. The geometric mean will be the same thing for this series, that is, will be equal to the square root of, or the cube root rather, of 9 times 11 plus n times 29 plus 2n. Now, this form won't give us anything special to look at, because this will give us a dead end. But what can we derive from the geometric mean to help us solve it? Well, we're trying to find a2, and we know that the square root with the cube root of 3, a1 times a2 times a3, will be the geometric mean of the following. So if we want this to be set to be equal to a's of 2, how can we write a better formula out of this? Well, we can raise both sides to the third power, so a2 cubed will be equal to a1 times a2 times a3. Now you see here that we have a2 here and a2 here, so we can divide a2 on both sides, and that means a2 squared will be equal to a1 times a3. So we have concluded a much better formula for us to use, and we can apply it to this problem, to the following geometric series. So the second term, which is 11 plus n squared, must be equal to the first term times the third term, which is 9 times 29 plus 2n. Now we see here that we have one equation and one variable. Hence, we can solve this variable. So if I write it to the upper right, we will have 121 plus 22n plus n squared is equal to, if we substitute a 9 into it, 1 carried the 8, which would be 26, plus 18n. And I'm running out of room, so we're going to scroll to the right for more. And we can isolate every term to the left-hand side. So n squared plus 22n minus 18n plus 121 minus 261 will give us 0. So we can combine like terms right here. This becomes 4n, and this becomes negative 041, negative 140. So n squared plus 4n minus 140 should give 0. We can solve this through the for the quadratic formula. So 2a negative b plus minus the square root of b squared, 16 minus 4ac, which will be plus 560, which will be the same thing as negative 4 plus minus the square root of 576 over 2. Now, 24 squared is a very special square because it is equal to 576. Don't believe me? You can take it into a calculator and you can verify it yourself. But this is a very special square that you should remember. And if you cannot think of it on top of your head, you can just do 25 minus 1 squared, expand it, and you'll get the following solution. But for time's sake, I will not be doing this. I'll be moving on with the question. So this evaluates to 24. Hence, we can divide 2 to get negative 2 plus minus 12. Now, we want to minimize this because it's given to us in a question. So obviously, subtraction will do so. So negative 2 must subtract it by 12 to give negative 14 to be our desired result. And now that means n is equal to negative 14. So that means we can simply just plug in n for the geometric series, and we will solve the following question. So 9 will therefore be 11 minus 14, and then 29 minus 2 times negative 14. Or 29 plus 2 times negative 14. And we're trying to find the smallest possible third term. So this evaluates to be a 29 minus 28, which gives us 1, bringing us to answer choice A.